basically, it is a tool that is designed to formulate PMR when we work with AMS farm, but not only, because it is used also, for example, in pasture farm, or when we feed the concentrate, the component, when we have a component feed. But right now we focus our attention how to use this tool in a robotic herd. I have an example. I am working with a couple of herd that are working with robot, and they started to work a few years ago. And step by step, we developed some additional features, and we modified the tool in order to make it robust and efficient. How I can describe how it works? I would like to start just describing that in 2017, we opened a collaboration with Greg Penner in Saskatchewan, and we provided the tool in order to put together some data in order to evaluate a possible strategy to define how much and how we can feed the pellet through the robot with an appropriate PMR. And we put together a strategy. I skip several slides. I go direct to the strategy. Based on that paper, we defined a strategy in order to formulate a PMR and decide how much how much pellet through the robot we can provide. Basically, we formulate our suggestion is to formulate PMR for the average of the pen in terms of milk yield, including a minimum amount of robot pellet able to guarantee the proper number of visits to the robot. We know that there are some cows that shouldn't have any additional concentrate through the robot, but we have to set a minimum in order to guarantee the proper number of visits. This minimum amount should be around 2.5 to 3 pounds per cow per day. In this way, when we formulate for the average of the pen, we should respect these constraints. The PMR without the minimum, this minimum 2.5 to 3 pounds, should cover around 100% of the requirements. Then when we add this minimum amount to the diet that is not included in the wagon but delivered by the robot, we should have around 1.2, 1.3% of the requirement, no more than 105. After that, we need to set a maximum. We do not want to feed too much pellet through the robot, because we know that there is a substitution rate, and we want to guarantee that our cows eat enough PMR in order to maintain the proper rumen health and the proper components, milk components, through the appropriate intake of PMR. So we set a maximum. We set the maximum amount using these constraints. We do not want to feed more than 3.5, let's say 3.5 pounds each visit. So if a high producing cow visits the robot, have a milking frequency above 4.5, close to 5, the maximum amount should be around 15 to 16 pounds per day. And the above constraints should be set for all cows, regardless the milk yield and the number of visits. In other words, I provide a minimum even if my cows produce less than the average, and I set the maximum to 15 or 16 pounds per day, even if my cows produce more milk than we can cover through this supply. So based on these constraints, we set a series of algorithms able to give us some answer. First, I formulate my PMR. Here there is an example. We formulate, in this case, I formulated the PMR, and now we can evaluate it without the minimum pellet. We are around 100% of the requirements. The average of the group is, 72, 73 pounds, and we have 100% of the energy. We are a little short in protein, but I want to monitor. I want to monitor the nitrogen through the rumen ammonia and through the rumen degradable through protein per pound of fermentable carbohydrate. These two numbers, I have a minimum, I think about a minimum around 1.10% and a minimum around 90 grams, 85, 90 grams, in order to be sure that my diet is close to be fine even for nitrogen. Now I add the minimum of the pellet I want to guarantee. No, sorry, this should be, we are in pounds, 2.5. I know that the system recognizes that this is the feed that is delivered by the robot, because I uncheck the checkbox right at the left of the name of the feed. All the feeds checked are included in the PMR. The unchecked feed is the feed delivered by the robot. I have everything set up, and then I go to the step feeding. The step feeding is the first step in the step feeding is to define what kind of AMS I have. In this case, we have a guided flow. The average feeding frequency is 2.8. I want to reach a maximum of over 120 pounds per day, and I want to set several steps having the difference between each step of 5 pounds. I set the safety threshold during the optimization. The system always consider the rumen health, and we can monitor the safety of our diet through different parameters. My preferred parameter is the physical effective NDF, and here we can set the minimum and the maximum of the pellet I want to provide. Let's say 2.5 as a minimum, 16 as a maximum. Everything is ready to run the evaluation, and in a relatively quick time, the system is able to provide his answer. Here you can see the different steps and with a range of 2 pounds, and step by step you can see that the range is defined by what we input here. We can see the predicted total dry matter intake, PMR plus robots. The PMR intake, I mean the PMR without the robot that is predicted to intake. And here we have the amounts of the robot, sorry, of the pellet. The system is suggesting to feed step by step, starting from the minimum until the maximum. And when it reaches the maximum, it continues to maintain it fixed even for the step forward. Between the parentheses, you have the amount of feed, the amount of pellet that it is estimated the cow eat for each visit. Of course, we start from the average to evaluate based on the milk how much visits we predict, and we split this total amount into these visits. The dry matter for the robot pellet, and in the yellow column you can see the programmed amount you should set in the robot software. What I mean that we know that there is some kind of refusal, and this amount refused is based on the total amount we offer. So based on this, we calculate how much refusal we should expect. We add the refusal to the amount the cow should eat, and we provide here the amount of pellet we should program within the AMS. The grams of concentrate of pellet per pound of milk, the expected range of intake based on the deviation we observed in the research I mentioned with Penner, Greg Penner. Here we can see step by step the allowable milk, ME and MP allowable milk, and we can see in green are shown the value that are in between the goal we defined for the step, in red when we are outside, above or below the level we set for each step. And you can see that when we focus on the cows with above 120 pounds per day, we are close for energy and we are almost perfect for protein. Then we have some parameters that can help us to identify if the different diet we are feeding to the different cows based on the steps we define are safe or not. We monitor rumen pH, the time of the rumen pH below 5.8, total starch, fermented starch, and the cost of the supplement and the total cost of the diet. Hey Dave, I may need a few minutes more. Can I continue a little bit?
Sure, go ahead.
We have a graph showing the intake. Total intake is the line. The 3 bars describe how much pellet the cow should eat. Light green, how much pellet we should program, and the PMR intake based on a substitution rate that now is set as 1:1. That means that each kilograms of dry matter through the robot we offer, the cow is gonna reduce the intake of PMR by 1 kilogram of dry matter intake, or 1 pound per 1 pound. It depends on the metric. Then we have an idea here in this graph. We have an idea about how this diet PMR plus pellet is able to meet the requirements or meet the target. The green box describe the target. The light blue bar, the ME allowable milk, and the yellow bar, the MP allowable milk. You can see that we are almost fine until, let's say, 110 pounds of milk. Then we start to become little short in energy. But please consider that at this stage, we do not consider any contribution by body condition score losses. So if we expect that at this stage, starting from 115, let's say, we can lose our cows can lose some body condition score, you know that a great part of that energy will be used and marginally for protein should be used for the cow to cover some requirements. So our expectation is that in reality, this energy in this section, the energy is not really short because it is partially provided by body condition score losses. These are the parameters that step by step are considered. In other words, we do not use for all the steps the average days in milk, the average milk fat, total protein, true protein, and body condition, but we monitor the evolution through the lactation curve and the curve of the components, what would be the expected outcomes, not only in terms of milk yield, but also in terms of components and body condition score evolution. There are several other aspects that are included in this tool. but I don't know if we want to move more in depth with these functionalities, or maybe Dave, you want to show how do you use this tool in your condition. Let me know what you prefer.
You can. Kurt, you have a.
Yeah, can we squeeze in 2 questions that I think are pertinent here?
Okay.
Hermano, can the system handle more than 1 robot feed?
Yes, it can handle 2 different feeds, no more than 2. I am not to use to include two robot feeds because in my perspective is too complicated to handle two different robot feeds, but the system is able to handle 2 different. For example, if I add a liquid feed, propylene glycol, maybe, okay, I tell the system that it is provided by the robots. I back to the step feeding. I want to set a minimum 0.2 and a maximum 0. Let's say 45. I run again the evaluation, and now you will see that a new column will appear here in order to the outcomes is not perfect, but again we are including let's focus on this column. This is the amount of the first of the pellet, and this is the amount the system is settings for the second phase.
Yeah.
There is an issue in the outcomes, but the answer is yes, we can handle two fees.
Okay. And the other was related to that previous graph showing the body condition loss. So with an extremely high production cow, what level of body condition loss do you think is tolerable before you need to reformulate? How do you feed that 180 pounds of milk cow?
The perspective shouldn't be related to the average cow, but should be related to the fresh cow. For the fresh cow, we use a different perspective. For example, we target we define the target not in terms of milk yield, but in terms of days in milk, and we want to monitor what happened until 70 days, having a weekly step, okay, using exactly the same constraints. I run a different scenarios, and in this case the system provides the same outcomes with a maximum of 10 pounds of robot pellet at around these days in milk. And in terms of body condition loss, sorry guys, we didn't remove the decimal places here, but okay. In this case, starting from the Kelvin, where we predict the body condition score, in this case we lost 0.9 body condition score after 70 days, starting from 3.19 plus 0.13, 3.4, and we lost 0.8, 0.9. I think this is acceptable. Otherwise, we should reformulate the diet.
And the wild card too is, we do not know how much intake, looking at some of the studies that were done, even Mike's study at Cornell when they took when they put the non-forage fibers in, the intakes on those cattle were just incredible. And I go back to the one
Yes,
guy that has.
yes, but this should be partially taken into account when you formulate the PMR. Because if you add non-forage fees and you get higher intake, you should be able to evaluate everything through the PMR formulation before to run the step feeding. You know what I mean?
Yeah. So just go back to the, can we go back to milk yield up there instead of days in milk? And then just for our example, as soon as that runs, and I know you're not a fan of this, but can we hold the base constant and then deviate up 5%? So what I'm asking the computer to do right here is to keep the PMR constant, but it can deviate to 5%. So go ahead and run it again. And we're just using the robot pellet. We're not using the propylene glycol. And it comes up with.
I excluded.
Yeah.
Can you see here that it is not checked, so it is working only with one pellet.
So what you did on the one scenario, so using this in around the barn feeding with some small dairies, who basically had the guy feed as much PMR as he could. And so I would go to allow changes, your button here, and then I would go down and make that step feeding. So that would be 4.75 or 5, 7.5, 10, 11.5, maybe 13. And then I could watch where I am on your allowable ME and MP milk over here, looking to see where I'm under formulating or over formulating. We could actually print up a report that just had the milk. So I did get my report working the way I used to have it.
Show your report, Dave.
Okay.
Show your report. Probably I didn't update mine report.
You may have given your computer a headache doing that. So let's see, where am I? Okay. And I actually don't have any customers using AMSs, but we did have, I think we're on version 3 of this step feeding now, Armando, is that right? Or 3 or 4, but in the early ones, I went out and found a PMR guy that was top dressing in the herd. We did something very similar to this. Again, the pellet would be in the step feeding, and then I have the best results pushing the TMR for guys and maybe allowing some deviation, whatever the cow's going to do, and then running the system. I've used forage percent as my safety threshold. And so one thing that we do need to do is talk about real quickly is that in the systems we all deal with, we we wanted to come up with, years ago, we wanted to come up with how could we define all the things that are in NDS to make sure that your cows stay healthy in one screen. And we came up with a well-being tab. And using this in the robot system can cause some problems because there are some compromises that you may do that you wouldn't do in a TMR. So you can actually make a subcategory within the system here, and then you can have a subcategory of robot. So that will loosen up some of the areas here in your, when you're working with the AMS system. So what I wanted to show was just that we can get a system. I like these results. I may clean this up a little bit. When you hand this to a guy, especially when he's walking around his barn, he'd never wanted to see these numbers. So what I would do is I would tickle these just a little bit so that he could walk around and do, you know, whatever he needed to do. And then,
And if you talk about the well-being, you can open the well-being tab from the small graph close to the I button in order to see which one the well-being parameters you set up for the robotic dairies subcategory in order to be able to understand why some of the cells are highlighted in pink or red based on this specific well-being.
so yes, in that system, the fermentable starch at 23.4 is showing right here as my upper borderline. It crossed that. So I have a pink. If it crossed the upper critical threshold, it would be red. So you can see that. But just using this system now, I feel okay, and I can walk through some of this by reformulating. I've got a bunch of things that I'm overfeeding in a bunch of these areas. So what I could do is I can come up and make a report, which is simply something I can print out, which shows basically the milk range and the pellet input amount. This was very simple, taking a lot of that information that is usually on the sheet. There's a lot of information on here. Milk range, you could use allowable milk, you could show ME and MP, you can show ruminal pH. For producers, what I wanted to do is give them a sheet that said, hey, look, here's what you need to do for this group of animals. The other thing, one last thing to show, and I'm going to jump in here and do only half the steps and allow this to run, is the idea that came up from I'm going to even do it to 20, just so I don't have to create so many steps here. The idea that came up from a producer or a user, sorry, I guess he does milk a few cows. You know who you are there. But his idea was this is not the same cow, which got us into this animal parameters, but also got us into the multi-step function, which really is a different function inside of NDS. And if we click on this, it will give us a multi-step look at all of these categories of animals. And then you can actually go in and start manipulating with the body weight loss. And the question always is as well, if this guy does have a 142-pound animal, it is, as lined out here, it's going to be a fresher animal in his system. It's not going to have the tank average of butter fat. She probably is mobilizing some long chain fatty acid, which we can't account for in the model, but her fat and protein are going to be less. and we can actually mimic some of this body weight loss in this animal. So the multi-step just goes through, it grinds through, and it creates a multi-step for these 5. So now you have, this is a function within NDS, and Hermano and the IT guys linked it together. So now it's showing the step from 60 to 62, 80 to 82. So I just chose these steps so that I didn't have to create as many. What it's showing me is intake, forage, the cost, and the nutrient analysis. But through the options, I can go to animal inputs for each of these. And now I can put in some body weight loss into this animal through here and here. They were able to mechanize a lot of the animal step down of days in milk and milk production, step down the amount of fat and protein of the average from the high cows, knowing that all the cows are not the same. But if I look down here, and if I put a little more body weight loss in that animal over the next 60 days, then if I go back to outcomes again, what's happened is this will reflect more milk from energy and protein coming off the body. So we have this in a tutorial there, so you can see the tutorial look at the step feeding system. This is an incredible piece of you know, computing and looking at the ration and giving us some idea of where we are. You know, this probably warrants a little reformulation here, but it is kind of a neat system that's gone through 2 or 3 updates and iterations. Penner's coefficient of variation is right in here, and you know, just a lot of neat features in this that I'm not sure are being used by a lot of users.
It is an evolving tool. We continue to work in order to improve its capability, and we always appreciate inputs from the users and idea from the users in order to make this tool more and more useful and easy to use.
So Hermano, I've been basically, as we've been working with this, I've been backing this down, you know, a little bit and adding a few more days in milk and taking the milk down so that it gives me a bigger range on that print off for users. So that's one thing, trying to get some people to use the tool better and use the print off. I think people want to see a bigger range on their print off, so that was the reason for doing that. Kurt, any questions that we?
Yeah, I mean, it is such a complicated program. There's requests to actually, you know, provide a template and go and have people keystroke along. Maybe something for the future. And there was a beef one about if you change from male to steer, does that really change requirements? And how sensitive is the program to climatic changes for beef, like raising outside versus?
Okay, let's grab one at a time.
Yeah, sorry.
That's all right. If you go to manual, and we have, this is the online manual. So if you're a registered user, you get all this. And I think the YouTube channel link is right here. So you don't have to remember our channel, but you can access it right here. And I think within If you go to all videos here, here is the last one that we did with Greg Penner.
Very different.
He
When you look across
no,
systems,
thanks.
we see
He gave his presentation, and we did a little bit more put in here. We can actually start, we can do a step video slower, and that way if you guys want to follow along, you can get on the YouTube, stop it, look at your program, start it again, and follow that way. Again, it is a huge chunk of software stuck in there with a lot of power. And so if you don't click something, or if you don't have something right, Kurt and I will try to get a current AMS feeding video up in the next 2 weeks. We'll do that because I know that's just really hard to follow. Hermano, from the early days on CNCPS, I kind of was talking to somebody, and I thought maybe they kind of downplayed a little bit of the environmentals on cattle outside. With that last storm we had in the Rocky Mountains and the High Plains area, it looked like we could get into 0 degree nights, and it took a severe wind with low temperatures, and it wasn't a gradual decrease. It kind of was a sharp kind of fall off the edge of the cliff kind of response. Have they changed CNCPS weather effects on cattle here in the last?
No. Nothing in this area has been changed in the last years.
Okay.
They focused on rumen mostly, but nothing in terms of requirements or environments. The minor institute is working with a management piece of the platform, but not the environments or how the temperature, wind, or something like that impact on requirements. Nothing changed.
Okay. And then the other question that Kurt rattled off, if you're looking at steers and intact males, again, if you have steers with no implants, they're not going to gain near as what bulls do. But any comment on that question?
For what I know, there are no difference in the requirements between male and steers. Maybe something related to the implant, but again, in the CNCPS, they do not consider the type of beef much. So I do not expect a different efficiency between the entire or castrated animals.
Would there be a difference in the energy metabolism? Maybe not the requirements, but how they.
Oh yeah. There is a difference, but the way CNCPS is predicting the allowable gain is the same. There is no options to evaluate through different ways based on the metabolism, as you said. In reality, we know that there are differences, but these differences are not taken into account yet. Other questions?
I'm typing in your verbal response into the online.
So as far as doing males, bulls, I'm not sure what I'd want to do with how much I'd want that average daily gain. There's a user sent in a question, and I think he's got somebody raising Holstein bulls. I know from exposure to beef industry and bull test stations and stuff.
There are two aspects that may have an impact when you switch between male, female, and steers. The first aspect is the expected mature body weight, not the input, but the expected.
Yeah.
And the other is related to the final body fat. It will be different. This difference is not really captured by the model, but we know that probably fat deposition is different based on the animal type. These two differences can explain some different outcomes based on the CNCPS. For example, you input 28%. Can you check the average daily gain right now? $2.25.
Okay, and I would probably, yeah, 2.95.
Okay, can you close? I am talking about CNCPS. Can you close the screen?
Sure.
Back to the animal and try to reduce final body fat to 25. My expectation is to have higher predictions, 2.4. So,
and that is just that same graph you were showing about, you know, how much energy it takes to put fat on, right? Towards the end of the feeding period.
Yes, yes.
Do I have to get to the beef model to show that? Yes.
Not necessary, but if you want.
Okay.
So the difference is that in the CNCPS, we may need to have body fat in advance, while, and we don't know, this is just an expectation, while with the beef broth model, we evaluate the body composition through all the period, the growth period. So we do not need to have this information in advance because it is the model to calculate the expected body composition. Other questions?
I think we're clear of written typed in questions. You guys have covered the differences between CNCPS and growth model.
So there is just one question there that said, you know, again, how do you, you know, how do you decipher between the performances and, you know, the Cornell and the beef growth model? And so the performances and those items are still calculating, they're trying to adjust the
Okay,
prediction.
Dave, you have to customize the screen. Check on the checkbox. Remove the French system and
Sorry.
add the beef growth model.
I was feeling kind of French one day. So really the true idea is looking at the Cornell system, that the megacals a day going into average daily gain through the beef growth model. That's what I found has been giving the best values when you're doing high starch diets on like the backgrounding and pasture animals and stuff like that. The CNCPS has been working really pretty well.
Yes, I agree. I agree. I agree. When you work with high forest diet, probably the CNCPS works better, even because the beef growth model was designed to evaluate low forest diet and growing and finishing animals, and not young growing animals. So that might be a difference. And in any case, I would like to recommend you to give the priority to the CNCPS model. And in case the CNCPS, even though the input are correct, sometimes the CNCPS fails to give you good predictions for some reasons. In that cases, you may want to compare those predictions with the beef growth model in order to have an additional view of your diet. And if you maybe want to consider some adjustments. The priority is always the CNCPS, and the beef growth model should be considered as an additional options that you can invoke if you want to make deep evaluations, or in cases where the CNCPS doesn't seem to work as expected.
And I think as I start playing with that, anytime you start going into these starch diets of, over 35 and stuff, I'm always going into the beef model as a description for that pen. And then using the beef growth model has given, even when I do my heifers on pasture and they're getting, 15 to 20 pounds of grain a day, the beef model does so much better job of predicting that because of the high starch diet. So
maybe one day we will be able to give you the green light to use only beef growth model, because it will work better than other models. But today we cannot recommend this. We only recommend to eventually monitor the beef growth model when you are working low forest diet, and when you think that the CNCPS is failing, even though you consider your inputs accurate enough.